Welcome. It's very nice to see you. So we have data mesh journey in Scania. Please share with us.
Perfect. Thank you so much. Hello, everyone. Very happy to be here. As mentioned, my name is August Johnson, Strategy Manager for the Data Mesh Initiative and Journey at Scania. And joining me today, I have my close colleague, Paul Zubin, who is the lead data architect for Data Mesh. So we thought we'd spend these 30 minutes to talk quite a bit about data mesh and the learnings and implementations that we've done during our journey.
Yes, so I'll take this over. So I would like to first set a context just to give you a holistic view. So why are we doing this? Well, Scania as a company, it's over 113 years old. It has legacy, it has history, and it is extremely decentralized. Meaning business domains, they have a lot of power and autonomy in their decision making and in the kind of products that they choose for data platforms. So it is definitely not the German structure that we have been listening to. So I just want to get the analytical data management structure overall, and then we'll get into how we have implemented data mesh, which August will talk about. So Scania as a whole, we have a lot of core business domains, most important ones being manufacturing, logistics, sales and marketing, a lot of service, finance, parts. But not only this, there are other domains which are new, like connected services, some other supporting domains like purchasing, common domains like HR, IT. So all of these domains, they have several applications and a lot of data platforms where they have all this data. And it's a good thing for us. They own all this data themselves. They understand it the best. So they don't depend on, let's say, one central organization, which is the IT, to use this kind of data. They understand the data best. So that kind of helps us with the data mesh perspective. We'll get into that. So from our perspective, from Scania's perspective, it makes a lot of sense because we are so decentralized. It makes a lot of sense for us to invest time, money, effort into the data mesh way of working. So the first part that we do, which our extended team helps us with as well, is that we get all of this consumable, understandable raw data into an open table format. We'll get into formats like Iceberg and Delta Lake as well. Now that raw data, that goes into an object store like S3 or ADLS. We are multi-cloud, we will always be. And the metadata of that, of all that data, that goes into a meta store. So that's the very first step that we do as part of raw data provisioning. Next is the interesting part, where because business domains in Scania are so decentralized, every domain has their own preference for tools. There are business domains which have been in this journey for a very long time, and they are happy with the tooling that they have, and they want to stick with it as well. There are other domains which have found other options, better options. Then there are business domains within Scania which have multiple data platforms within the same domain, and they're trying to talk to each other within the same domain as well. So when it comes to data products, we'll get into that a bit more later on as well. When it comes to data products which are developed within a single business domain, in those sort of scenarios, the business domains have complete leisure to select the kind of analytics suites that they need. And if the consumers of that data is also within the same business domain, then they can use this sort of a structure where they can go berserk. They can use the data vendor, the data platforms that they need to develop data products. But when it comes to cross-domain data products, where we have to combine data from multiple business domains, that is when we kind of enforce a structure where the data product development teams, they will have to stick to a single data platform suite. And over here, a query federation kind of an approach also helps us a lot. And when it comes to cross-domain data products, there is a certain coercion to get all the business domains to use a single suite of tools. Now, in this sort of a structure, we have to bring it all together. Now, this is where all these, I would say like a fabric or a blanket which comes in, wherein we have common Git tools, we have infrastructure as code, CI/CD, we have a single data catalog and a data quality tool as well. And then, at least what's dear to us, open table formats like Iceberg, Delta Lake. And also, this part is important, where we have a single data product governance protocol. So there is a central data board in Scania which decides what are the governance policies that all domains across Scania should follow. And those data governance policies are implemented as code. We don't go around and do things manually. These are implemented as code, and we'll get into that as well. And then all of these data products, they have to go into a common marketplace. And this marketplace is where all the consumers see all that information. We'll get into that as well a little bit. Now, then there are certain points like master data management. There are a lot of key data points like customer, products, assets, suppliers, you name it. There are a lot of very key data points. All of those data points have master data management tools or teams in place as well. Then we have the regular culprits, which is observability, monitoring, orchestration. So this is how we see our overarching analytical data management setup. And over time, we architected, we re-architected, designed, redesigned, develop, redevelop. So when we do that, we always keep these principles in mind. So it doesn't matter who does it, but we have to keep these principles in mind. And we've segregated into two kind of sections. One is the data platform principles. How do you make it robust? And the other part is from a data mesh perspective. What kind of principles should a true data product follow? Now, with this in mind, we'd like to zoom in to one of these hexagons which we identify as a data product. It can be any one of these. And the next slide would be around we trying to show what does a true data product mean in Scania. It's not just a table share. There's a lot more to it. And for that, August,
yes, thank you, Paul. So tying back to what Paul mentioned earlier about the principles and sort of the baseline that we're working from. So first of all, we know that there's an increase in demand for analytical data, and in conjunction, we have different parts of Scania moving to different cloud providers based on their needs and what works for them. So one of the key challenges that we faced in the data mesh journey, and continue to face to some extent, is to find a balance in embracing the autonomy of these business domains while keeping an alignment in what constitutes and make up a data product. So the first step on that way that we took was to agree and standardize on open table formats, just as Paul mentioned. So predominantly Iceberg, but also Delta Lake for cases in which that is applicable. So with this, we enable data to be interoperable, meaning that we sort of get away from this vendor-specific lock-in that these different business domains are in, and allowing for the data to be consumed and packaged into data product later on. So with that, we sort of achieve, since ownership is already sort of embraced by these domains, we achieve ownership and interoperability. Now, the second thing that we introduced as a part of data mesh, or the implementation, is the self-serve data platform. And it contains three parts. The first one being the data product builder, which allows the domains in a self-serve manner to build, define, version control, and deploy their data products to a common unified marketplace. So in here, we can set standards and common structures in which a data product should follow. And this includes things such as binding data contracts and also observability related pages for the data product itself. And what's so good with this is that we have a governance engine that works within this platform, meaning that non-compliant data products will be stopped from being deployed into this platform or marketplace. And what's so good with this, and also one of the key reasons why we opted for a vendor-agnostic platform, is that we can adapt it to work with Scania's own internal tools and platforms for governance. So in our current version of the platform, it essentially talks with these different tools and makes sure that, hey, you as a producer, have you defined your data product in here? Have you followed these steps? If yes, then it'll get a green light. If no, red light, and it will be stopped, but the producers will know why and what they need to revise. So moving on, so once the data product has been deployed, we then have the marketplace in which you as a consumer can find the catalog, you can click on the data product, read the description, see the data contract and understand, hey, so what are the terms and conditions around using the data? What is the uptime? And so on and so forth. How much should I pay for compute when working with the data? And that is also one of the reasons why we opted for an open table format in multi-cloud. That is because we enable data, we enable the separation between storage and compute so that producers don't get scaled costs with having a large consumer base. So when we tie all these points together regarding ownership, what it entails, the guidelines around it that we have, in conjunction with the discoverability of data products, having a self-serve data platform with a governance engine that works in an automated and computational fashion, that is in essence when we believe a data product has been achieved. And when we use these open table formats, as Paul alluded to, we have the query federation engine on top of it that helps abstract away for the consumers which sort of cloud provider the data is coming from originally. And instead, we have role-based access control in the platform in which they motivate the request, and then once approved, they can immediately start working with the data. Yes. So moving forward to the learnings and improvement areas.
So this has been there for a few months now. And as we built this and as we tried to architect this, there were some learnings, there were some improvement areas that we could immediately identify. So I'll get into some of them. So first thing was around the maturity levels. So when we talk to all these business domains through workshops, the one thing that we realized is most of these domains are in very different maturity levels. Like if I take an example, the sales and marketing domain of Scania, they are at the forefront of doing things, trying to find out new information about customers, products. They are fairly mature and they have already built in around 29 to 30 data products themselves as a business unit. Now, when we talked to them, our approach was a little different. We had to make sure that they were compliant with the certain principles that we showed earlier. But they were more or less agreeing with all of them, but then our effort was a bit less. to get them onboarded into such a platform. But there are other domains which, because we have this legacy and history, there's a lot of on-premise applications as well. For them, this is fairly new. It takes a lot of time for us to make them realize the benefits out of it. They do realize it over time, but it takes time. So the maturity level is very, very different when it comes to us talking to these domains and getting them onboarded. And I wanted to mention this because another thing that we realized is early adoption is very key. Just imagine if there is just one domain here with few data products and you have tons of consumers consuming it. That isn't really what we are trying to achieve. We want all domains to come in here and then cooperate with each other so that consumption and the responsibilities from a domain ownership perspective also gets distributed. So just being one domain in here is fairly lonely. They see themselves as torchbearers, but they see a lot of pressure on themselves as well, that they have to provide not only their information, but they get requests, okay, can you do this for me? Can you do that for me? So overall, early adoption is very key, as we see it, for a data mesh framework to succeed. Another thing is being in the cloud. A lot of principles that we have mentioned here, maybe not directly, but the separation of storage and compute, interoperability. There are a lot of things that the cloud instantly provides, a lot of solutions in the cloud instantly provide, but it will be a Herculean task to do that elsewhere. So those were some of the learnings. The other things were in terms of improvement areas. Now, as we did this thing, we saw interoperability in a certain manner, meaning we started off with technical interoperability. Okay, let's use Iceberg, let's use open table formats, let's get ourselves away from all these vendor lock-ins. But that's the technical interoperability. We are also realizing that we need a semantic level interoperability as well. We cannot get stuck to AWS Glue as a catalog or a Snowflake as a data catalog. We need something that unites all this, just like the open table formats does the unison. The other part was bitemporality. It's a fancy way of saying history of all the tables. Initially, when we started off, we thought, okay, let's have all data products have all the history of the data. But then over time, we've started realizing that not everyone needs history all the time. There are very specific use cases who need history, and the data products can provide them, but it need not be a mandatory option that you should have history for all of your output ports in the data products. I could get a lot more into that as well, but in terms of data contracts, what we've realized that we have to have it binding, but then we cannot have it so complex that it takes a lot of time for us, or for the producer and the consumer, to build and communicate to each other and build and consume and produce data products. So we need to somehow find a balance between having a binding data contract in place, but also having it simple so that we can just follow a certain template and, okay, I've ticked off all my requirements. And the technical implementation, I would say, is the easier part for data contracts. But then having that agreement, okay, let's go with this. That is the challenge. And then the other part which we see is, as we work with multiple clouds, Google prefers certain things, AWS prefers certain things, Azure prefers certain open table formats. So it would have been, in an ideal world, it would have been great if, let's say, we prefer Iceberg, so if Iceberg was the only open table format available, that would have been awesome, but that is not the case. So when it comes to open table formats as well, we need something that converges us the ways of working. Now, we are trying to streamline things. This is where, and this is more in a brainstorming, troubleshooting phase, where we want to converge all of this open table formats into one, and also have a REST catalog which will take care of that semantic level of the metadata. Yes, so this is what we wanted to share with you. As a summary, I would say we've had a few sessions around platform engineering. So I would say what we presented to you today is like a culmination of data engineering, platform engineering, DevOps, and we are trying to culminate all of this into a developer portal. There was a workshop earlier around developer portals and the scenarios that we need to use for developer portals. So this, I would say, is a culmination of all that in the analytical data engineering space. Yeah, I hope this was worth your time. Thank you.
Thanks so much.
Thank you very much. Questions? Okay.
You mentioned internal developer portal. What part of your organization will be responsible for it? Is it an extension of your team, or where does it fit in the org structure?
Yes, so the developer portal is maintained and developed by an central IT organization. And it's part of our team. We call ourselves an enablement team for data mesh. So this developer portal is an extension of our team. We have developers who do this.
Okay, any more questions? Yeah. How big is the team? And I would like to add, I had also one question. How are the teams organized? Meaning multidisciplinary profiles, etc.
Yes, so from if I answer your question, how big is the team? We are part of an enablement team. So it's me, August, we have Naveen right here. So you have one architect, one or two developers, and then we have a support system of consultants. I would say 2 or 3 of them on a rotational basis who help us out with this. And that is from the platform, the self-serve platform perspective. From an overarching perspective, it is a bit different. We don't have a diagram. In fact, we have it in our documentations. But so it's like a house structure, I would say, wherein the basement is where all these enablement teams reside, and the walls is basically the preachers, the evangelists, the advocates who go and talk to all these business domains. And on top is the governance team. And that, I think, is the most important part of making this possible. And that governance team has participation from all the business domains and all the management level people as well. And they are the ones who decide what are the policies that go into this sort of a self-serve platform. I hope that answers the question.
So it's like this, right?
Not like this, but this way. And then there is a house, there's a basement here, and then this is the enablement, this is the governance, and this is the self-serve platform. And this is where all the vendors, the data platform vendors reside. And you could attribute it to business domains as well who are developing data products. So, yeah, this way.
You see how we can play, you know? Thank you. Thank you very much. A big applause. Great talk, guys.